We can solve the product of the roots of a quadratic equation even without using the roots themselves. We're just going to use the coefficients of the quadratic equation. Let's start by deriving first the formula from the quadratic formula itself. We have here x is equal to minus b plus minus the square root of the discriminant over 2a. We know that in this formula, we can separate them into two different roots, x sub 1 and x sub 2. For x sub 1 would be the sum of our numerators, and for x sub 2 would be the difference of our numerators. So this is just on the derivation process first, because we are not going to use the roots themselves, but we're going to look for appropriate formula using the coefficients only. Look at our x sub 1 and x sub 2. We have here a combination of two different rational expressions for each. Let's separate them. So for x sub 1, separate the sum of the numerators using the same denominator. For x sub 2, separate the difference of the numerators using the same denominator to a. Now, notice our x sub 1 and x sub 2 are now both binomial expressions with the same first term, negative b over 2a, with the same second term, square root of b squared minus 4ac over 2a, but they only differ with the operation separating them, plus for x sub 1 and minus for x sub 2. If we are going to talk about product of these two roots, we are multiplying two binomial expressions with the same first term, same second term, but differ on the operations separating the terms themselves. So we are going to expect here the product of two conjugates. That means that the product should be a difference of two squares. Simply take the square of the first term, square the second term, and use the difference or subtraction as the operation separating them. So once we took into this, look at the exponentiation. For your first term, that would become b squared, and 4a squared for your denominator. And for your second term, the radical expression for the numerator will be removed, but the denominator will still be subjected to an exponentiation. Now from this, we have the same denominator, so we can combine them into one expression with the same denominator for a squared. But notice that what will happen for our numerator, that's b squared minus b squared are 0, and you have minus negative 4ac, so that's positive 4ac over 4a squared. Simplifying further, you will have here only the ratio of c over a. What does this mean? If you are going to solve for the product of the roots, even without the roots themselves, use the ratio of c and a coefficients, and that's already the product of the roots of your equation. Let's have an illustration here. Let's have x squared plus 3x minus 10 equals 0. We know that a is 1, b is 3, and c is negative 10. So without even using the quadratic formula to solve for the roots of this equation, nor other methods, simply take the ratio of c, which is negative 10, and a, which is 1, and that automatically gives us negative 10 to be the product of the roots. If you're not convinced with this, let's try to factor our equation, and let's use the roots themselves to determine whether it's really negative 10 as the product of the roots. So we can factor x squared plus 3x minus 10 equals 0 by x minus 2 and x plus 5 equal to 0. By zero factor or zero product property, we can separate them and solve for the roots, which are 2 and negative 5, or vice versa. Now what is the product of 2 and negative 5? That's actually just equal to negative 10, equal to the ratio of c and a earlier. So again, if you're just simply asked about the product of the roots and you're not given with any roots, you can automatically take the ratio of c and a to get your product. Now we have a lot of videos on our channel, specifically in the playlist called Quad Quiz, for some explanations and other demonstrations in automatically solving for the product of the roots of the quadratic equation even without the use of the roots. So please view them on your own time.